All right, we're now going to be going over part C of this question, which is the following. Implement the method is unique in the hash map class that returns true if and only if the hash map has unique keys, i.e. it does not contain two or more equal keys. Assume all implementations of the list and set interface have been imported. Hint, consider objects with invalid hash codes. All right, and before we actually dive into the method, let's take a look about how this map is built. So for the class 61B hash map, we have the following. It looks like we have an array, and in each array pointer, it points to a linked list of entries. And then it has a size value here. And the entry class is structured like this. As you can see, it is a private static class with a private K key and a private V value. And this is the way an entry is constructed. Now, let's think about how we can actually go about and do this problem. So if we want to find out that there are two or more keys that are equal to each other, we need to keep a track of all the keys in the hash map so that we know that we are not encountering the same key again. And in order to do that, we can simply have a sort of collection. It can be a list or a set, as you can see here, that will keep track of all the sort of keys in the list. So let's go ahead and let's initialize a collection that will allow us to do that. But before we do that, it's important to pay attention to this hint. Consider objects with invalid hash codes. Because we are considering objects with invalid hash codes, if we want to use a data structure that uses hashing as a part of its sort of central structure, it may not work, and sometimes you may be able to get an object you may be able to get two objects that are equal, but in the hash map, they'll be in different rows. So what we want to do is rely on a structure that does not rely on a data structure that does not use hashing. And in this case, we can simply use a list. We'll have a list of keys, and then we'll just call this keys equals, and we'll just use an array list for this. Now, to actually find out if the key, now that we have initialized a list where we can keep track of all the keys, what we need to do now is the following. We need to sort of find a way to iterate through all the entries in the map. And that way we can then go to each map entry, see if that key is not already present in this keys list. And if it is not, then we simply add it to the list. And so as you can see here, we are given a double for loop, which makes this very easy for us. We can have the outer for loop go through each linked list in the map. So it'd be something like this. Linked list, entry, KV. We'll call this chain. And then it's each linked list in a map. And this is a for each loop, by the way. And then what we want to do is go through each entry in the linked list. So what's going to happen is something like this. We have an entry here, and then it would be K, V. We call this entry, and we know it's part of chain because it's part of the linked list. And now what we have to do here is the following. Like I said earlier, if the key that we're currently working with, or if the entry currently has a key that is already in the keys list, then we want to return false. And if it is not present in the list, then we simply just add that key to the list. So what happens is this. If the keys dot contains entry dot key, this is a way to check to see if the current entry key that we're working with has not already been seen in the hash map. And if it does contain it, then we return false. And then what we can do in the case that it doesn't contain the entry dot key, we simply add it to keys, which is simply this. Keys dot add entry dot key. And then as you can see here, this is just going to go through the entire for loop. And if we go to the entire for loop and we don't return false, that means that every single key in the map is unique. And as a result, we can return true at the end if needed. And yeah, that's part C.